I would like to continue the real numbers chapter, that is fundamental theorem of arithmetic. In this chapter, till now we have learned one theorem, that is Euclid division lemma. That is the first theorem we have already learned, and we have learned some applications also. Now in this we will just see what is a fundamental theorem of arithmetic. It is very simple. Every composite number, I think you understood what is a composite. Composite is which is not prime. So I think you know what is prime number. Prime number is having only two factors, that is 1 and itself. Okay. So if 1 and itself is there, then that is a prime number. That means all the numbers are divided into two categories: prime numbers and composite numbers. So prime numbers will not have any factors. Only two factors will be there, and they are called prime number. I will give you example. For example, 2 is there. So then what happened? There are only two factors. For example, 4 is there. So 1 is a factor, 2 is a factor, and 4 is a factor. So 4 is not a prime number. It is a composite number. Okay. Let us say 5. 5 is also having two factors. 1 is a factor, 5 is a factor. So it is a prime number, right? Prime number. Now I'll go for 6. Okay. 1 is a factor. That means 1 is a factor for all the numbers. 1 is a factor, 2 is a factor because 2 divides 6, and 3 is also a factor, and 6 is also a factor. Therefore this is a composite number. Okay. Prime numbers will have only two factors. Say this is 1 and 5. Like that, if you take a 10, right? So then what happened? 1 is a factor, 2 is a factor, 5 is a factor, and 10 is a factor. So two factors commonly. That means 1 is a factor of every number and the same number itself. Okay. So most of the field people immediately, if it is 15, they think that it is a prime number. Don't decide any number just like that. You just check how many factors are there. 3 is a factor, 5 is a factor, and 15 is a factor. So it is not a prime number. It is a composite number. So before you decide whether the number is a prime number or composite number, you should always check whether it is having two factors or not. Okay. Now what fundamental theorem says? 1.2 theorem. It is fundamental theorem of arithmetic. Every composite number, I'll write in short form, can be expressed as a product of prime factors. So here one more word came, factor. Okay. Factor is a very simple thing, as a product of prime factors, and it is unique. You do in any way, it is unique. Okay. You start from the big number, you start from the small number. It doesn't have anything. It will be always a unique number. So this is the fundamental theorem of arithmetic. It looks so funny. It's a common fact. Everybody well aware of this rule. Okay. Every composite number can be expressed as the product of prime factors. Let us see. Let us take from 4. 4 is a composite number. How do you write this 4 as a product of prime factors? You divide it. This is the division, continuous division process. You take first prime number 2 and 2. Okay. So 4 can be written as a 2 into 2. You can write it in the exponential notation also, 2 to the power of 2. For example, 40 is there, for example, 40. Now 40 how to take? Again you take, this is a continuous division process and I am dividing. You take the first smallest prime number which divides 40. So 2 is the smallest prime number which divides 40. So 2 20s are 40. Again take one more prime number. It is a continuous remainder came, quotient came, and again we have to divide it, because there is no remainder problem here, because remainder won't be there, remainder is 0, then only this 2 will be a factor. Again the next quotient is 10, 2 10s are 20. Again you have to take there are two possibilities, you can take 2 or you can take 5 also. So 2 you can take 5. So the factors are 2 into 2 into 5. So how are you going to write it in the exponential notation? We can write it 2 to the power of 3 dot 5 to the power of 1. 1 you can write it, or you can leave it like that. So sometimes 40, some people will be doing like this. They will start from the 5. Yes, 5 is a prime factor. You can take 5 also. So then 8, right? Sorry. Then here you should not take a 4. 4 is not a prime number. You should take always the prime number here. Prime number which divides the dividend. So 4. Again 2. You do in any way. So 5 into 5 into 2 into 2 into 2. So it is 5 into 2 to the power of 3. So 5 into 2 to the power of 3. 2 to the power of 3 into 5. Both order, whatever the order is there, but it is the unique factorization. Okay, so this is a simple thing you have learned in class 6 and 7. So again it is given, right? So it is just a reminder process. Okay, so now on this you might be having some questions in the examinations on this concept. Okay, so just I will give you, for example, I will just give you, this is one number divided, 2 is a factor, we don't know how much is the number. Okay, again this is a prime number and this is a composite number. Again this composite number can be divided into product of 2. So this one, and again there is one more box. Okay, so 3 boxes. Again this is a composite number 2, and this is one more box. Again this is divided into one more group. This is 3 into 3. Now you have to find out all these boxes. What are, fill in the blanks. So that means you should find out this number. How are you going to? You come from down. So this number is divided into expressed as the product of 3 factors. So 3 3s are 9. So in the first box 9 will come. Again 2 9s are 18. The second box 18 will come. In this third box 18 will come. In this 36 will come. In this 72 will come. So this is a very simple questions. You don't need to worry about these questions, it's because they are very much easy. So like this you might be having a question. One question I'll just give you. 6 to the power of n can end with what number? And end with 0, and end with the digit 0 or not? That means you have to check whether this number end with the 0 or not. So this ending digit you should be able to find. This is a new concept. For example, I will just give you an example here. 2 to the power of 3. So when 2 is their base, so what will be the end number? End number. What are the possibilities of end number? 2 to the power of 1, 2, you may be getting 2. If it is 2, you may be getting 4. And if it is 3, you may be getting 8. If it is 4, 2 2 to the power of 4, 16, you may be getting 6 also. End digit, when the base is there, end digit may be 16 also. 2 to the power of 5, 32. Again 2 came. Okay, 2 to the power of 6, you can say 64. 4 came. So that means when you have a base 2, whatever the power is there, exponent is there. So the possibilities of the end digit is only 2, 4, 8, 6. For example, if it is given 2 to the power of 536 is there, what will be the end digit? The end digit of this category, of this number, may be any one of these things, 2, 4, 8, 6. So this is a simple general knowledge questions you should be able to understand, right? So now we will go with this question. That means we have to check whether 6 to the power of n, the end digit 0 or not. You have to check it. Okay. So let us take 6 to the power of n. Because 6 is the composite number, let us write 2 into 3 whole to the power of n. So then what happened? 2 to the power of n into 3 to the power of n. That means we have converted 6 to the power of n as a product of prime factors. Okay. So product of prime factors. Then what happened now? It depends. N, what will be the end digit? So 0 will come when 5 as a factor. Okay, in this you have 2, 4, 6, 8 will be there. If 3 to the power of n is there, when you multiply with some number, the last digit should be 0. Okay. So when it will be 5 2s are 10, 5 4s are 5 6s are 5 8s are. Only with 5 if you divide, it, then only the end digit may be 0. So now 2 to the power of n, whatever the n may be, the end digits will be these things. Okay. Now if 3 to the power of n has a 5 as a last digit, 3 to the power of 1, again you can check it like this. 3 will be there, 3 to the power of 2, 9 will be there, 3 to the power of 3, 27 will be there. So I am writing the last digit. 3 to the power of 4, it's 1 will be there. 3 to the power of 5, because I am aware of all these numbers, I am writing it very fast. So 3 will be there. That means 3 is repeating. So that means in this only these 3 numbers, 4 numbers will have a last digit. That means 1, 3, 7, 9 only will come. Okay. So in this there is no 5. Therefore, this 6 to the power of n is not having the factor of 5. That means last digit 5. So then what happened? This 6 to the power of n cannot end with 0. That means in this answer the last digit cannot be the 0. So now whatever I have discussed, whatever I have written in the nicely point by point you can write, because this question is an examination question. It has come in the previous examinations. So this is how to decide the last digit is 0 or not. Okay, last digit 0 means, so if 2 is there, if 5 is one more factor, then there is a possibility last digit might be 0. Okay, so you have to understand this question logically, and then you have to go ahead. Okay, so some more questions are there in the textbook. You can do those things, right? So this is what is a fundamental theorem of arithmetic 1.2 theorem. Okay, so there is one more question, one more application is there. Show that 13 into 31 into 41 into 63 plus 41 is a composite number. So this is also an important question. This type of question also in the examination it has come. So first what he has given? He has given 4 numbers product of 4 numbers. 13 is a composite number, prime number. 31 is prime number. 41 is prime number, whereas 63 is not a prime number because 63 has a 3 is one factor. So you will get a one product number, and this is a composite number. Okay, so now you have to prove that this is a composite number, right? So now in this 41 is there here, you take 41 as one factor. So then what happened? 13 into 31 into 63 plus 1. So is equal to this x number, let us say x. So this x number, so whatever 41 into some number will come here, this is x. So that means this x has 2 factors other than 1 and x. 1 x is the number, so 1 is a factor, we didn't write here, but other than 1 and x there is a factor 41. Therefore x is a composite number. X is a composite number. Okay, so if you are, because we are taking 41 as a, so 41 is one factor. 1 is a factor for example for all the numbers, and x itself is a number factor, and besides these two, 41 is also one more factor. Of course we are getting one more factor also. Whether y is prime number or composite number, it makes no difference. 41 as already we have got extra factor, therefore it is a composite number. So it looks confusing, but understand it slowly, one by one. Okay, slowly. Whenever you have a confusion in any question, you should not think it fastly. Slowly, right from the first line, first word, first number, say you have to read it nicely, and slowly you understand. Then this confusion will go. So for today, this is enough. We will see you in next class. Okay, bye.